So welcome to this. This is the Further Math Support Program online revision for Edexcel Statistics 1. What we're looking at in this session is aspects of the normal distribution. So what you're expected to know on S1 is quite algebraic and being able to use tables and things like that. So the first key thing is really understanding that when you've got a normal distribution, this beautiful bell-shaped curve, that the area underneath that curve represents probability. You can't integrate the curve because it's too difficult, so we are using tables to actually find them, as you'll see later. To be able to use the tables, you need to be able to standardize to a z value. Okay, so that's a really important aspect of a normal distribution. As I've just said, you need to then be able to use cumulative tables to find probabilities and understand the difficulties that they have in so much that, for instance, there are no negative z values. Also, you need to be able to use the inverse tables, which are generally called probability point tables or percentage point tables, to find the value of z. So effectively we're going backwards. And also you need to be able to set up equations in mu and or sigma squared, so you've either got one equation to solve or a pair of equations to solve simultaneously to enable you to find the population parameters of mu and sigma squared. So it's quite a difficult topic, this. It's very certainly going to come up, so we've got to be very aware of it. So we have a question here where we're given information about the heights of a population of women are normally distributed. So I personally will be doing this every time. So it's normally distributed with the mean of mu and a standard deviation of sigma. And it is known that 30% of women are taller than 172 and 5% are shorter than 154. So really, before answering the question, I'm actually going to try and write this in some maths. So I know that the probability that x is going to be greater than 172 is equal to 0.3, and I know that the probability that x is less than 154 is equal to 0.05. Now, because the normal distribution is continuous, we don't really care too much about these inequalities as to whether or not they include or not. Okay, so we don't need to worry too much about that. Anyway, the question is then asking us to put this information onto a picture. So you've got to understand a few things to do this. So first of all, here's your normal distribution, and the mean will be in the middle. And you will have this beautiful bell shape. Now, that doesn't really get you any marks. It's ensuring now that the probabilities are correct. So we're told that 172, we've got to put that on my x-axis somewhere, has a probability above it of being 0.3. That tells me it has to be on the right-hand side. So this area here has to be 30%, corresponding to this value of 172. Likewise, we're told that 0.05% is at the bottom, so that has to be my value of 154. So they're testing your understanding as to whether you understand that area as probability. So actually you do get a mark here for drawing a bell shape, but you've got to make sure it has these sort of, it looks like a bell. So if you drew like a, I don't know, a triangle, then that's not going to get you any marks. You get 1 mark for putting 154 and 172 roughly in their correct places, and then you get another mark from labeling the areas as 5% or 30%. So notice here, we're quite happy to accept 0.05 as a value. We're happy to accept percentages as a value. So again, you could indicate that as 5% if you wished. It wouldn't be a problem. So again, students are unfamiliar with drawing in the exam, so you've got to make sure you can do this. So then we're told that we need to show that we have a particular equation. So reminding you, the distribution was this. We don't know what mu is, we don't know what sigma is. And again, if you've read the whole question, it's quite clear that you're trying to find both of these things. So it's quite clear that you need to create a pair of equations and then solve them simultaneously. So the value here has 154 in it, so we can realize that that links to the fact that the probability of x being less than 154 is equal to 0.05. So the trick is, we're trying to find out some values here. So we know that we're dealing with 5%. So we can use our table. This is our percentage points table. So we're doing this backwards. we can use our percentage points table to tell us that when probability is 0.05, we end up with a Z value of, well, it's 1.6449 in size, but you need to recognize, if you go back to your picture, okay, let me just do that very quickly. If you go back to your picture, we're definitely on the left-hand side of the mean. Now, if you're on the left-hand side of the mean, that means that your Z value will be a negative value. Okay, so your pictures are really, really helpful here. Now, Z is a standardized value. So there is a formula, x minus mu over sigma, will standardize your data for you. And please make sure you do it this way round. X minus mu over sigma is Z. Don't think really if you're to the left of the mean it's the other way around and then you have a positive Z, because that just creates something extra for you to remember. So if you always do it this way, then you've got a greater success at getting the answers here. So what is X? X is the value of 154. So we've got 154 minus mu over sigma, which again we don't know, must equal the Z value that we've just been looking at. So you can see you've now got all the right numbers that are required. It's just a question of rearranging. So 154 minus mu equals negative 1.6449 sigma. So we can clearly see that mu is equal to 154 plus 1.6449 sigma. Okay, so this sort of question, it gives you 3 marks. You get 1 mark for correctly standardizing. Okay, now that method mark is for standardizing irrespective of using plus or minus here. Okay, obviously it's a good idea to use the correct thing, but demonstrating that you can use the table properly will give you a method mark. If you get the correct value then, so negative 1.6449, then you get a secondary mark for that, and then an accuracy mark for getting the equation out at the end. So the question continues and asks us to obtain a second equation and hence find the values of mu and sigma. So this time we're going to be using the 172. So I had written that the probability of x being greater than 172 must equal 0.3. Now, in my head, I'm not particularly keen on probabilities that are not cumulative. In other words, they're not pointing to the left. So I'm going to bear this number in mind because it's quite useful. But that will give me a value of 0.7. Now, you can see that 0.7 is not in your probability table, your percentage point table. But 0.3 is. So I'm going to use that value. So for both of these, 0.3 and 0.7, we're going to have a Z value of 0.5244. But again, if you cast your mind back to the diagram, 172 is clearly on the right hand side of the mean, and that indicates that we're going to have a positive Z value. So we then standardize in the same way. So x minus mu over sigma is equal to Z. X in this case is 172, so we've got 172 minus mu on sigma is equal to 0.5244. And again, rearranging this, 172 minus mu is equal to 0.5244 sigma. So we've then got 172 minus 0.5244 sigma will equal mu. So to get the other equation out, we're only really going to be giving you 1 mark for that. Okay, and realistically, you're only going to get that mark if it's correct. Okay, and again, you should be making sure you're using the 0.5244. Where lots of people go wrong with this question is they decide to use 0.52. Okay, if you're lifting a number from a table, please make sure that you are using the exact values that are stated, and then you're not going to go wrong. So we now have a pair of equations. We've got 172 minus mu equals 0.5244 sigma, and we've also got, and you can rearrange that to make mu the subject actually, so yeah, we'll use that one underneath. So let me just get rid of that. And we'll use the better one. It depends really on how you want to solve your simultaneous equations. But there's something rather nice that happens here that I want to make sure you're using. So we've got mu is equal to 172 minus 0.5244 sigma, and we're told also from previously that mu is equal to 154 plus 1.6449 sigma. So what you can do quite nicely, because you're always going to get mu, is you can actually just equate these to each other. Okay, so we've got 172 minus 0.5244 sigma is equal to 154 plus 1.6449 sigma. And that tells me, if I just rearrange those, that I have 18 is equal to 2.1693 sigma, and dividing through tells me that sigma is equal to, if I'm going to write this to three significant figures, is 8.30. It should be 8.2976, but we can round to three significant figures. Then we just substitute this back into either equation. I'm going to use the bottom one, so mu is equal to 154 plus 1.6449 times by 8.30, and that will give you also the value of mu. So in this particular case, the value of mu will be 167.648, but as I say, 168 would be sufficient for that question. So you're getting 3 marks for solving this simultaneous equation. Okay, 1 for creating the second equation, and then it's method accuracy, accuracy. So basically you get 1 method mark for setting up a simultaneous equation and eliminating a parameter, and it's easier to get rid of mu. You then get an accuracy mark for getting sigma right, and you get another accuracy mark for getting mu correct. So once you've worked those out, the question continues. Okay, so we can rewrite our distribution now. X can be modelled as a normal distribution with a mean of 168, we're allowed to use that value, and a standard deviation of 8.30, we are allowed to use that value. Okay, and we're asked for the probability that she is taller than 160. Okay, so there's a variety of ways of doing this. I'm very much a fan of turning the probability around. I'm then going to standardize the 160. So if I standardize 160, that's going to give me 160 minus 168, all divided by 8.30. And if I do that, that's going to give me a z value of minus 0.92. Now, you can only really use z values to 2 decimal places, so we don't really have too much issue if you're calculating z to use to do that. Now it's negative, so to work out a negative z value, what we do is we look up the positive. Okay, so when z is equal to 0.92, p is equal to 0.8212. So the corresponding probability for this z value, we take it away from 1. So that's going to give me 0.1788. Okay, so carrying on the question, this probability here is this bit that I've just worked out. So that's 1 minus 0.1788, which you might recognize is actually the value that we were looking for. And it's the same over there. Now, again, this is not the quickest way of doing this question, but it's a very logical, very analytical approach to it. Okay, and again, it makes sure that you're finding the right aspect of probability when we do this. So this is a 3-mark question. Again, you get 1 method mark for doing a standardization. You get 1 mark for getting the correct z value, and then you get an accuracy mark for actually getting the correct value at the end. Okay, so let's look at a different question now. That question was quite nice because it actually pretty much covers everything that you need about the normal distribution. That's why I quite like it. But here we've got the weight x grams of soup put in a tin by machine A is normally distributed. So again, I'm sort of wanting to write my distribution. So x can be modelled as a normal distribution with a mean of 160 grams and a standard deviation of 5. Now notice I'm leaving it as 5 squared, and that's just because it helps with the notation later on. So in part A, we want to find the probability that we contain more than 168 grams. So again, I think that's pointing the wrong way, so I'm quite keen to swap it round. Okay, if I then standardize this, I've got z is equal to x, which is 168, minus the mean, which is 160, divided by 5, and that's going to give me a z value of 1.6. So again, I'm looking at 1.6. My z value is positive, so my probability is 0.9452. So again, that's this aspect, so that's going to give me 1 minus 0.9452, which gives me my answer to part A, which will be 0.0548. So this is a 3-mark question. Similar sort of pattern. You're getting 1 mark for doing a standardization. You're getting an accuracy mark here for doing the correct thing with your z value. Okay, so I'm really looking for a 1 minus somewhere. So by having 1 minus here, you're sort of picking up your second mark. And then of course your final mark is for getting the probability at the end. So part B, it says find W such that the probability of x being less than W is equal to 0.01. So this is your percentage table again, which is in your formula booklet. And I know that for a probability of 0.01, I need a z value of 2.3263 in size. But again, if you go back to a normal distribution, what we're really looking for is a value of W such that the area to the left of it is 0.01. So I'm definitely on the left hand side, so as a consequence it has to be a negative z value. Okay, so then we can unstandardize it. So we've got x minus mu over sigma must equal this z value. So multiplying that all through and tidying it up, we're going to get W minus 160 is equal to 5 times by minus 2.3263. Taking over the 160 and adding it is going to give me 148.37. So this, again, is a 3-mark question. Your method mark, as with most of these, is for recognizing that you are trying to use a z value of some description, and you're standardizing. So the method mark comes in from standardizing, the W minus 160 over 5. You get an independent mark for choosing the correct z value. And again, if you do not choose 2.3263, okay, you run the risk of losing marks. Now, in this particular question, they did allow you to round, but don't expect that to be the usual thing to do. Always use the full value from the table as possible. Okay, and then your accuracy value obviously comes from getting anything that rounds to 148.37. So we continue. In the next part of the question, it says the weight Y grams of soup put into cartons is normally distributed. So Y is normally distributed with a mean and a standard deviation. And we're given 2 probability statements, and we're asked to find the value of mu and the value of sigma. So this again is forming equations in terms of mu and or sigma to find them. So I'm going to do this one because I'm not constrained by the question telling me the format. I'm going to save myself a little bit of work. I've got the table I need here to show you what's going on, but it might mean you can solve the simultaneous equation a little bit more efficiently. So first of all, 0.99 and 0.01, they are called complement values. Likewise, 0.9 and 0.1 are called complement values. They will give you the same z value. One will be positive, one will be negative. And if you're happy to remember that, it makes using these tables really, really helpful. So, to do that, we don't know what the mean is. You could draw this as a picture if you wish, but you don't need to. So here we go. We've got the probability of y being less than 160 equals 0.99. So, it's a left probability. I'm a great fan of that, and it's bigger than a half. That tells you are bigger than your mean. So as a consequence, you're going to be dealing with a positive z value. The only problem is 0.99 isn't there, so you have to be using this one here. So if we call this aspect 1, with aspect 1, we've now got the fact that if we standardize, we're going to have 160 minus the mean, that's over sigma, that's z, and that must equal positive 2.3263. So that gives me 160 minus mu is equal to 2.3263 sigma. I'm going to leave it like that. If I then look at situation 2, the probability is pointing the wrong way, so I much prefer to write this as the probability of y being less than 152 is equal to 0.1. Now, it's a left probability that's less than a half, so it's less than the mean, so my z value will be negative. So I still look up 0.1, but when I come to standardize it, so 150 minus mu over sigma, that's going to give me a negative z value of 1.2816, which, I'm going to write it here and you'll see why in a minute, will give me, 152, that will give me 152 minus mu is equal to minus 1.2816 sigma. Now the reason I've done this is, if I now subtract these equations, that will nicely eliminate mu straight away. So if I do that, I'm going to get 8 is equal to 3.6079 sigma, and I can now divide through to find sigma, and sigma turns out to be 2.21. I can then substitute that into either of my equations. I'm going to put it into the bottom one, so 152 plus 1.2816 times by 2.21 must equal mu. All I've done is rearrange this equation a little bit, and if I calculate that, I will get 154.84. And again, with all of these, anything that rounds to 155 will be correct. So let me tell you how these marks are allocated. You get one method mark for standardizing. Okay? And you only get the method mark once. So of course we've standardized twice, but it only occurs once. You get independent marks for each of your z values. So again, if they are rounded, you run the risk of losing marks if you're not careful. So that's method 1 for standardizing. 2 B marks are given for reading the numbers from the table. You then get another method mark for eliminating mu. So if you eliminate a parameter, you will get, correctly of course, you will get another method mark, and then you get an accuracy mark, 1 for sigma and 1 for mu. Okay, so these normal distribution questions are hard, and you've really got to get your head around how they work. So again, make sure you've gone through lots of past paper questions with them, and then make sure you've learnt the ones that you've found difficult.